Now we are going to pick up some of the concepts we learned from our last lesson. And here we've got an example that has a diagram, and we have a number of squares in each diagram. So let's create a table of values from our diagram, from our images. So we have the diagram number, and we have the number of squares. So we have diagram 1, 2, 3, 4, and 5. And we're going to talk about count up the number of squares. So we have 1, 2, 3, 4 squares for number 1. 1, 2, 3, 4, 5, 6 in number 2. And 1, 2, 3, 4, 5, 6, 7, 8. And now if we look at this, we know that we are, again, increasing from 2 to 6, which means we're adding 2. We're increasing from 6 to 8, we're adding 2. And so I can guess, or if I not guess, but follow the pattern and say that I'm going to go from 8 to 10, and then from 10 to 12. And let's just count to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And for the 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so the pattern works. Now let's write the equation. Again, we're increasing by 2, so we're taking 2 times the diagram number, and we have to think, if I take my 1, I take 1, multiply it by 2, I need to get 4 from that because the diagram number 1 has 4 squares. Well, 1 plus 2 is just 2, and to get from 2 to 4, I need to add 2. So I'm going to add 2 to that, and that gives me the number of squares. And so we have our example, we have the equation that describes that example. Let's now look at this other example. We've got the relationship between the hours worked and the money earned. Well, let's do this exactly the same way as we were previously. We've got dollars, and from 28 up to 35, I've added $7. When I go from 35 to 42, again, that's $7. So they've given us the variable here, h. I take 7 times h. So now I have, if we test the 4 times 7 needs to give me 28. And oh, that's exactly what it gives me, is 28. So I don't need to add or subtract anything. I just have 7 times h. So 7 times the hours that I work will give me the money that I've earned. Let's look at another example. Oh, we've just done that one, so we'll go to here, and I'm just going to stretch this out a bit, make it a bit bigger. So, student example. This pattern is made using 1 centimeter square tiles, and our pattern continues. So let's start again. We've got our figure number. This time, it's rather than diagram number, we have our figure number, and we have the number of squares again. And so figure number 1, 2, 3, and 4. So we're being asked to write the equation that relates the area. Oh, so I need to change this. I need to stop just jumping right in. I need to write the area, A, and that's measured in centimeters squared, to the figure number, N. Okay, so if this is 1 by 1, we have an area of 1 squared, and this is an area of 2 squared. And now I have 1, 2, 3, 4. Let's do the next one. 1, 2, 3, 4, 5, and 6. And 1, 2, 3, 4, 5, 6, 7, and 8. And so we can see that we've got a nice pattern again. I'm just going to clean these up because we're going to need them again shortly. So we've got 2 going to 4. Again, I'm adding 2. 4 going to 6, I'm adding 2. 6 going to 8, add 2. So it's 2 times the number is going to give me my area. Now, if I take 2 and multiply it by 2, that just gives me my area. I don't need anything more. Let's see if it works. I take 2 times 2, that will give me 4, which is perfect. 3 times 2 gives me 6, 4 times 2 gives me 8. So we have our equation. A is equal to 2n. Now, let's go to B. Write an equation that relates the perimeter P in centimeters to the number n, the figure number n. So we're going to change this up a bit. Rather than determining the area, we're going to determine the perimeter. So that's our new question. So we want to do our perimeter compared to the figure number. Now, the perimeter is only what's on the outside. So this joined one, lines aren't considered a part of it. Each line is a centimeter long. So I have 1, 2, 3, 4, 5. Oh, 6. So figure number 1 has 6 centimeters of perimeter. Figure number 2 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So figure number 2 has 10 centimeters of perimeter. Let's do figure number 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So now we're seeing a pattern. 6, to get to 10, we had to add 4. From 10 to 14, we're adding 4. So I'm going to predict that from 14 we'll go to 18. And let's count it just to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So we've got our pattern figured out. We know that if we're adding by 4 every time, we're taking 4 times the number. If I have, now we're going to figure out the whole equation. The perimeter is equal to 4n plus or minus something. I take 1. 1 times 4 gives me 4, but I have to get to 8, so I'm going to have to add 2. 1 times 4 gives me 4 plus 2. Oh yeah, that gives me 6. I think I said I have to get to 8, but I have to get to 6. Let's test it with the 2. I have 4 times 2 plus 2. 4 times 2 is 8, plus 2 gives me 10, and so that's exactly what I want. So the relationship from the perimeter, for the perimeter, is 4n plus 2. Now we're being asked to determine the area and the perimeter for figure number 25. Well, we could go and draw every example, every figure from now to 25, but it's a lot easier to recognize that we have a relationship, that we can use an equation. So we have the area is equal to 2 times the figure number, and our figure number is 25, and so our area is equal to 50 centimeters squared, because our area is defined to be in centimeters squared. Let's do our perimeter now. Our perimeter is equal to 4 times 25 plus 2. So 4 times 25 is 100. 100 plus 2 gives us 102 centimeters. And now we have our number of centimeters for the figure number 25. Let's try one more example. Again, I'm going to just increase this size a little bit. So our pattern, we've been given a table this time. So we check and make sure that our numbers, our x values are increasing, and we can see they're going up by 1. And so I can compare here. And if I'm going up by 1 on my x, I'm going up by 3 on the y. Each time I'm adding 3. So my term number, n, is multiplied by 3, and then I need to determine what I'm going to be adding or subtracting to give me the term value. So let's see, if I take 1, multiply it by 3, and I have to go and get myself all the way to -5. Well, this is 3, positive 3, so I have to go down 3, and then I have to go down another 5, so I'm going to go down 8. So I think I have to subtract 8 here, because it's a subtraction because I'm decreasing, and it's 8 because to get from 3 to -5, I would have to take away 8. So let's test it with this one. Okay, so 3 times 4 minus 8. 3 times 4 gives me 12, and then I'm going to subtract the 8. Oh yeah, that gives me 4, which is exactly what I want. So that's a good test. We could test every one of them, but we don't need to. So we have v is equal to 3n minus 8. Now, we're asked to determine the value when n is equal to 21. So v is equal to 3 times 21 minus 8. Well, 3 times 21 gives us 63, and then with the 63 we're going to subtract 8. 63 subtract 8 gives us 55. So when n is 21, v is 55. Let's do the next one, c. This is a little bit different because they're giving us the term number. Which term number? So they're asking for the term number, and they're giving us the value. And so where we were substituting in for n last time, now we're going to substitute in for v. So I have 82 is equal to 3n minus 8. So the first thing I do is add 8 to both sides. That gives me 100 is equal to 3n. And now I can't add. So 82 plus 8 is not 100, it's 90. So now I have 90. I'm going to divide both sides by 3. And I do that, and I get 30 is equal to n. So the term number is 30 when the value of the term is 82. And now we're going to let you take some time to do the practice.